Solving nonlinear inequalities. So what do I mean by nonlinear inequalities? All the problems we did, what was the highest power of x? 1. Not in this section. So you might have a problem like this. X squared minus 3 greater than 2x. That's a non-linear inequality. Highest power is 2. Now the way I solve these, that's me. Everyone is different. My first step, I move everything to one side. And me personally, I like the x squared to be positive. So in this case, I'm going to move the 2x to this side, and this becomes what? X squared minus 2x minus 3 greater than 0. Step number 2. Let's factor this one.
X minus 3.
What is it?
X minus 3, x plus 1.
X minus 3 times x plus 1. I like that. Greater than 0. So now, step number 3, I'm almost done. I want you to find the value that will make it equal to 0. Find the values that will make it equal to 0. Just equal. What value or values, maybe more than one here, that will make this expression equal to 0? Not greater than or equal, just equal to 0.
Positive 3.
So x minus 3 will be 0 when x equals what? 3. And x plus 1 will be 0 when x equals what? Negative 1. These are my critical numbers, critical values. I could have stated this: find the values that will make each one equal to 0. Each term, each factor. Not a term, factor is a better choice here. And step number 4, which is the last step, take a test point. Test point in each segment. What do I mean by that? Here's the number line. This is my negative infinity somewhere here. This is my positive infinity right there. My critical numbers are what? The minus 1 and what? The 3. These are the numbers we found right here. Now notice here, if you take a look at the expression, did they have an equal sign in it here? Was there an equal sign in the problem? No, so these will be what? Open circle. And my answer is either going to be here, here, here. I'm not sure where. So how do we find that answer? The last step says what? Take a test point in each segment. Let's pick a value less than negative 1. Any number. Negative 2. Okay. Plug it in into the original problem. What's negative 2 when you square it?
4.
Minus 3 is 1. Is that number bigger than? What's 2 times the negative 2?
Negative 4.
Is 1 bigger than negative 4?
Yes.
Yes. This piece is a solution. Let's take a number between minus 1 and 3. 0 is always a good number. It makes the math easy. Is 0 squared minus 3, is that bigger than 2 times 0?
No.
No. That's not a solution. Let's pick a value more than 3. 10. Any number. Is 10 squared minus 3 bigger than 2 times 10?
Yes.
100 minus 3 is 97. Is that bigger than 20? Yes. So this is a solution. So I found the two pieces. From negative infinity to where? To negative 1. Not included. Union, add to it. From where to where? 3 to infinity. And that is the process I'm going to use every single time. Let's try another one. X squared minus 4x less than 21. What was the first step? Move them to one side. Yes. What's the second step? Factor completely. Is that x minus 7? X plus 3, is it? And step number 3, let's find out when is each one of these factors will be 0. When is x minus 7 will be 0? When x equals 7. When is x plus 3 will be 0? These are my critical values. Now we'll do what? Test points.
Are test points actually necessary?
Well, how would you know which section? Because notice when you're multiplying two things to be less than 0, that means this has to be bigger than 0 and this has to be bigger than 0. That's one case, so you can do them that way. Or this has to be less than 0 and that has to be less than 0. So you got to find out what each one is. So the test point makes it a little bit easier. So this is the negative 3. This is the 7. And again, there is no equal sign, so it's an open circle. I'll pick a number less than negative 3. How about negative 5? Tested. Negative 5 when you square it is what? 25. Minus 4 times the negative 5 is what? Plus 20. Is that less than 21? No. Right? That's 45. Between negative 3 and 7, I'll use the 0 again. It makes my life easy. 0 squared, 0 minus 4 times 0. 0, is that less than 21? Is 0 less than 21? Yes, that's a solution. Now what about bigger than 7? 10? Any number. 10 squared, 100 minus 40. Is that less than 21? No, I don't have to waste my time on it. So where's my solution? From where to where? Negative 3 to 7, none of them included. Let me try another one that doesn't look like this, a little bit different. What about if you have a fraction? That's also nonlinear. Well, I can't move it to one side. It's already on one side. I can't factor. I'm done. Well, when is each one going to be 0 then? When is the x minus 9 going to be 0? 9. When x equals 9. So that's my first critical number. And when is x plus 15 is going to be 0? X equals negative 15. So these are my critical values. Again, you take your test points now. I'll put the negative 15 here. I'll put the 9 here. Less than negative 15. What should we use? Negative 20? What's negative 20 plus 15? Negative 5. What's negative 20 minus 9? Is that bigger than 0? Any positive number is bigger than 0. That's a positive number. I don't care what the value of it. Yes. Any positive number is bigger than 0. Yes?
So the critical values are just any numbers that fall to the left,
That-
in between, and to the right.
The critical values are the value, in this case, that will make the bottom and the top of the fraction 0.
The test points are the ones that fall.
Correct. The test points are the ones that will let you know which section is going to be the correct answer. What the critical values do is going to take the number line, divide it into the number of pieces. So if you have 3 numbers, you'll have 4 pieces. If you have 5 numbers, you have 6 pieces. Then you're going to test each one of them. So let's take a number between negative 15 and 9.
0.
0 is perfect. 15 over negative 9. Is that bigger than 0?
No.
That's a negative number. Any negative number is not equal to greater than 0. No.
The last one's yes.
Well, it's not always the case. So,
Why did it matter?
yep, probably. But I don't want people to think once you find the first one, yes, yes, no, yes. No, it changes. So in this case, yes. I just don't want to make a statement always like if you see a pattern, because you probably notice a pattern. But no, we can actually make them not work out that way. It goes yes, yes, no, or no, no, yes. You know. So now let me try another one here. The 10 plus 15, which is what? 25 over 1, that's a positive number. Any positive number is greater than 0. Yes. So my solution from where to where? Negative infinity to negative 15, not included. Add to it, union, from 9 to 8, negative to plus infinity. Now, I know you're probably thinking, like, what do I care about these? Where am I going to use these? I just made me think about them. Well, not just, I mean, let me just give you a problem. Let's say I have this problem. I said y equals, and I don't care where the question came from. I'm doing some math, I end up with that answer. And the question is what? What's the domain? Find the domain. The domain is the x values. Well, when you look at that, that tells me what? I need to make sure x over x plus 3 minus 1 has to be what? Greater than or equal to 0. You can't take the square root of a negative number. You can do the square root of 0. You can do the square root of a positive number, but not a negative number. So solve that one. That's a nonlinear inequality. Now, if I want to add fractions, I need something. What do we need? Anytime you add or subtract fraction.
You need to have a common denominator.
Yes, common denominator. So the 1 can be written as what? X minus 3 over x minus 3. And if I combine them, I will have what? X minus x, which is what? Gone, 0. And 0 minus a negative 3. Think about this. 0 minus a negative 3. What is that? Positive 3. Oh, wait a minute. Was that a plus? My mistake. That was a plus on the bottom. So that'll make it a minus 3 here.
I'm so confused.
Yeah. I guess I fell asleep there.
Would it make it a positive 3 on top?
No, because that's minus.
Oh, the minus.
0 minus the 3 makes it a negative. I fell asleep there. So that becomes my expression. I want it to be greater than or equal to 0. Well, you know what? I said, find out what value makes the top 0. When is the top going to be 0? Never. Minus 3 in this case will never be 0. When is the bottom going to be 0 here? When x equals negative 3. So you only have one critical value to deal with. Only one. So when you take your number line, you're trying to cut it now. Here's the negative 3. And the negative 3 better be an open circle. Why? You see you have greater than or equal to. Why is the negative 3 open circle, not a closed circle? I have greater than or equal to. We always figure there should be a closed circle. But how come I do that in open circle?
Negative fraction.
You have a fraction. Can the bottom of the fraction be 0?
No.
Notice if you let it equal to 0, what's negative 3 plus 3?
0.
Can you divide anything by 0?
No.
Because it's in the bottom. So the negative 3 is actually the bottom of this fraction. That will never be 0. If it is 0, I got a major problem. So now I'll take a test point, and left of negative 3, maybe I'll use what? Negative 10, you said?
Sure.
And to the right of negative 3, what do we use? 0? Is that what you said again? Perfect. I can plug them into this. If I did the math correctly, I can test them really right there. If I know my math is good. If I'm not sure my math is good, I'll go back to this one, the original problem. I have faith in my math, so I'll go negative 3 over when x is negative 10. What's negative 10 plus 3? Negative 10 plus 3. Negative 7. Is that bigger than or equal to 0? Yes, because that's a positive number. Any positive number is bigger than 0. Yes. Let's try the 0. Negative 3 over 3. Is that bigger than or equal to 0? No. So my problem now, my domain is what? From negative infinity to negative 10, not including either one.
Why is it negative 10?
Oh, whatever that point. Thank you. Long day, long night. I should just do one video a day instead of 4 or 5 at a time. So that's nonlinear inequalities.